In this video I'm going to go over parts of Domain 1, which is the foundations of chemical formulas and how we write them. And first we're going to look at how to determine the charge of a transition metal using Roman numerals. So transition metals can form more than one type of cation. So for example, iron, which is Fe, can form a positive 2 ion or a positive 3 ion. And so the way we can tell the difference when we write it is that the charge of the cation in an ionic compound is written as a Roman numeral. So if I were to look at the periodic table here, the transition metals are the metals that are in between the s orbital here and the p orbital over on this side. And you see things like iron, for example, forms positive 2 or positive 3. Something like tin or titanium can form a positive 2 or a positive 4. Copper can be a positive 1 ion or a positive 2 ion. And so, for example, like let's say we had iron 2 oxide. This is a compound of iron and oxygen. This Roman numeral 2 means that that iron has a positive 2 charge. You could have something with iron and oxygen that's iron 3 oxide. In this case, iron has a Roman numeral of 3 after it, meaning that that iron has a positive 3 charge. So very simply, if you have a compound that is ionic and there is a Roman numeral after the metal, that Roman numeral indicates the charge of that metal. Now let's take a look at performing an atom inventory of a compound. This is simply just being able to determine how many atoms there are inside of a compound by looking at a couple things. So to determine the number of atoms in a chemical formula, both the coefficient and the subscripts need to be examined. So coefficients can tell you the number of molecules or atoms that there are of that substance, while subscripts tell you the number of atoms within or inside of that molecule or part of that molecule. So for instance, I've got right here 2H2O. The coefficient is something that goes in front of a compound, and so my compound here is water. And so this coefficient of 2 says that I have 2 of everything that follows, in this case H2O. Subscripts, sub means under and script means to write, so this is a number that is written under an atom. This subscript of 2 means that there are 2 atoms of hydrogen in a molecule of water. Now let's take a look if we had both subscripts and coefficients in an example here. Now, let's say my compound is C6H12O6. This is glucose. So here I have a subscript of 6 on the carbon, subscript of 12 on the hydrogen, and a subscript of 6 on the oxygen. And I also have a coefficient of 2, meaning that I have 2 of these C6H12O6 molecules. So I need to look at both the subscripts and my coefficients here if I want to know how many carbons, hydrogens, and oxygens there are in this compound. So let's start with carbon. Well, there are 6 carbons in one molecule of glucose, but remember I have 2 molecules of glucose. So 2 times 6 would give me 12 total atoms of carbon. I have 12 atoms of hydrogen in one molecule of glucose, but once again, remember there are 2 molecules of glucose, so I have a total of 24. And then 6 atoms of oxygen in one glucose molecule, but I have 2 glucose molecules, so I have a total of 12 oxygen atoms. So overall, I have 12 plus 24 plus 12, I have 48 total atoms that are written in this chemical formula right here. And here's some pictures to kind of show you some other examples. H2O, water. There is no subscript of 1 here, So if something is just written without a subscript, assume that there's one. We don't need to write it. That's just more work. So here, 1 molecule of water, right? We've got 2 atoms of hydrogen and 1 atom of oxygen. If you were to put a 2 in front of H2O, that would mean you have 2 molecules of water. Here's 1, here's the second. That would give me 4 atoms of hydrogen and 2 atoms of oxygen. I could also have, here I have H2O2, which is hydrogen peroxide. I have 2 hydrogens and 2 oxygens, 2 H atoms, 2 O atoms. Okay, and last but not least, we have how to define and recognize a polyatomic ion. So let's take a look at that word and kind of break it down. Poly means many, and atomic means it relates to atoms. And hopefully we know by now that an ion is a charged particle. So what we have here is an ion, or a charged particle, that is made of many atoms. And so there are a lot of these, and I'm not going to have you memorize them all. So oftentimes you'll be given a table to refer to different common polyatomic ions. So for example, something like acetate is made up of many atoms of carbon, hydrogen, and oxygen, and it is an ion, and it has a charge, a negative charge. And most of these polyatomic ions tend to be negatively charged, but there are some positively charged polyatomic ions like ammonium. So let's take a look at an example of an ionic compound that has a polyatomic ion in it, magnesium hydroxide. Magnesium has a positive 2 charge, and it is with OH. And I actually have 2 OHs. And so when you have parentheses like this around the OH, this 2 right outside the parentheses means that you have 2 of everything within the parentheses. So what I have is I have an OH polyatomic ion with a -1 charge, and I have a second OH polyatomic ion. And I know that because of the 2 outside of the parentheses, saying that I have 2 of everything inside of the parentheses. So I have my positive 2 charged magnesium, and I have a total of 2 negative charges with the 2 hydroxide ions, so I can form an ionic compound of magnesium hydroxide. Okay, give the practice problems a shot, and I will post the key on Schoology.